Alexander Spiridonov, a solution architect from NVIDIA. I'm specializing in GPU compute acceleration, and today I will present NVIDIA RAPIDS Spark plugin on Azure Synapse. Today I will talk about NVIDIA Synapse collaboration. After that, shortly about NVIDIA RAPIDS plugin. And after that, I will present two demos, one about Azure Synapse Visual Studio project and another one about XGBoost notebooks on Synapse.
The first slide is describing on a high level our collaboration activities. First of all, they are of course including support of the current Synapse analytics infrastructure related to GPU and RAPIDS. Currently, Synapse is providing RAPIDS version 21.12 on Spark 3.2.1 and NVIDIA T4 Azure VMs. Second, NVIDIA and Microsoft are constantly upgrading Synapse environment with the latest RAPIDS releases. For example, just recently RAPIDS 21.12 was released in Synapse, allowing to work with decimal precision up to 38 digits, 128 bits. Previously, we were concentrated on ETL Synapse subsystem. Now, we are starting to collaborate on analytical part too. First of all, it will help naturally at a GPU accelerated machine learning and deep learning, working after ETL stage on the same Apache Spark framework running under Synapse. We are starting on GPU acceleration of Synapse ML and will extend it to the whole ETL ML DL pipeline. In parallel, we are actively working on our profiling and benchmarking tool. Later, I will add more details about that. And of course, we are jointly working on providing publications and presentations, helping our customers to use our platforms more efficiently. In the next several slides, I'm adding more details about our collaboration and our future plans. One of the main advantages of RAPIDS is that no code change will be required for end users of Apache Spark SQL or Apache Spark. All changes are on the physical plan level. This slide demonstrates an example of how RAPIDS is changing query execution. It looks almost the same, but GPU is working on columnar data and physical plan operations executed on GPU. They will have kind of hard to see, but on the right side, all operations they have GPU prefix.
To finish the short review of RAPIDS, I would like to mention scenarios that are the most efficient with our plugin. First of all, it's proved that SQL with high cardinality joins, high cardinality aggregations, and high cardinality sorts are significantly faster on GPU with RAPIDS compared to CPU. The same is true for window operations, especially for large windows. Plus, compared to Spark on CPU, RAPIDS is very efficient for transcoding, for example, encoding Parquet and ORC, reading CSV. Decompression on gzip is significantly faster on GPU too. And it's important to mention that CPU and GPU code is the same in all comparisons. Solving data-related problems can be done through one of two ways: data science or business analytics. Each solution comes with its own advantages, and choosing one depends on a lot of factors like your data, business needs, type of queries, and so on. Azure Synapse meets these challenges with a single service to provide limitless analytics in a unified experience. With Azure Synapse platform, you can load your data, run ETL pipelines, store the data back in a data lake, load them into a warehouse, and build sophisticated pipelines according to your business needs. without having to worry about infrastructure at any steps of your pipeline. Now I will show you two demos. The first one is to demonstrate how to run predefined query against GPU and CPU pools using Visual Studio. And the second is about running machine learning XGBoost notebooks on Synapse using GPU and CPU. Okay, let's create new project. Will be console application. Next, let's call it test query. It will be predefined query against the blob storage. 2. Place it in the same. Next, let's select .NET Core, create. Okay, this is the template program. First, we will add required dependencies. We will add them using NuGet packages. The first one is Azure Core. Install. Accept. Okay, it's here. Next one is Azure Identity. Install. Accept. Okay, next will be Microsoft Synapse. That's the last one. Accept. Now we have all dependencies, and let's change the template. I already have created the test. Okay, that's the one. Okay, let's build it. Success. Now let's run it. And okay, first step is authentication. Next, if we go to monitoring, yeah, you will see this query test 3 is submitting. Actually, if you click here, you will see Livy. Usually you'll see the Livy log once it's running, and after that you will see the Spark UI. Yeah, that's starting pretty slow. Let's go back to the log, and I already had previously running jobs. We will come back and check it again later. The text of this application is this one. Let's go for the code. First of all, I am using a Synapse client from the Synapse package, and doing some authentication and including required packages. After that, specifying workspace and the pool name I'm using. I'm running a predefined query It's just a SQL query. And after that, setting Spark configuration. And this is again standard thing. You can go to the Rapids site and you will see how to set it up. And after that, basically loading Rapids, because we want to use it for the GPU. And after that, it runs the query as a parameter for the job. It's extremely simple, just to show you the communication between Visual Studio and Synapse. And this thing is kind of interesting. This is the trigger basically to enable GPU jobs or disable GPU jobs. If it's commented, it means Rapids is enabled and we're running on GPU. But if we will uncomment this, it will run on CPU. Okay, let's go back to the monitoring. Still in submitting. Let's check. Yeah, see, it's already running. Let's go back until it's finished, and I will show you the previously created runs of the same code. And this one was running on CPU. It means Rapids was false in the configuration. In here, this is the standard UI, Spark UI. And if you go to, let's say, SQL and check the graph, you will see the standard graph with operations, but please notice, I already talked about this in the presentation. All operations, they don't have a GPU prefix. It means everything is running on CPU. But if we go back to our current job and launch the history for the application, it takes time to load the Spark. Okay, now if you go again to SQL and click on the job, see, you can see now it's running on GPU, because all translated operations are using GPU prefix. That's basically the way to monitor and launch job in Visual Studio against Synapse. Thank you. Now the second demo about XGBoost on Synapse using GPU and CPU. First is CPU version of XGBoost, and I'm running this on a CPU cluster. And the second one is GPU base version, and I'm running this on a GPU, previously created GPU cluster. For CPU, let's launch it. It uses XGBoost libraries. They currently saved in blob storage to link with the notebook. And after that, it creates the environment with libraries. Next, in a notebook, basically with creating label and features. And after creating a session, this is how I'm loading data. It's actually very simple because it's publicly available data set, and I'm taking only 1 month to run it. And after that, we need to do some conversions because the data set, publicly available data set, is actually not in the right structure, and because of that I'm doing some queries to select labels and features. And after that, for CPU version, as you know, we need to use vector assembler for feature columns to join them in one column. Yeah, just finished. The last job is still running, and on the last stage we're doing regression fit, and we will see this is the job. We can see how it's running, and once it's done, it will output how long did it take to run. See, this is the current time, and we will see almost all jobs finished. Yeah, in parallel actually we can run a GPU version. Let's go back. Okay, this job is done. Last job finished. Yeah, training takes 72 seconds in CPU case. Now if we go to GPU, again it's starting the cluster, and the loading again basically the same libraries, but plus GPU cluster already has Rapids installed. That's why it will run on GPU, and the same code, the same structure to load, the same conversion of the data, and even simpler. Now we don't need this part to do the vector assembler, because the library is taking everything as is. And now let's see, is it here? We actually can go to monitoring and see we have these two clusters running. And if we go to Spark pools, we can see how much memory allocated, Spark application. Let's see, GPU taxi. This is the one is currently running. Again, we can see the status of this notebook, and if you go back to notebooks, yeah, GPU configuration finished. Let's go to the last stage. See, it's still running. It takes 41 seconds compared to 72 seconds on CPU. We can see it's faster on a smaller cluster which has only 3 nodes. That concludes the presentation. Thank you so much for attending. It has been an amazing collaborative experience with Microsoft in bringing the GPU capabilities inside Azure Synapse. And we look forward to further enhancing these capabilities through new features and added functionality in the future. Thank you, and have a wonderful rest of your day.